Okay, so we're going to balance number 11 and 12, which are a little more involved. These are combustion reactions, so I'm going to write combustion reaction. You'll learn more about those later, okay? Combustion reactions involve a hydrocarbon, which is predominantly made of hydrogen and carbon, and it's reacting with pure oxygen, which is O2, and you are producing carbon dioxide and water in your products. Okay, so we're going to make it look like this. What I want you to do is highlight the O2, because when you have a combustion reaction and you've got O2 by itself, you want to balance oxygen last. So I'm going to put a box around O2, and we're going to start with the carbons. If I put a dashed line down the arrow, you've got one carbon on each side. If you look at the number of hydrogens that you have on the left, here I have 3 plus 2, which is 5. That's an odd number. When you have an odd number of something, it's really hard to balance it. So you want to put an even number in front of it, like 2, which is going to double it to make it even. So here I have 2 carbon. So I'm going to put a 2 in front of CO2. Then I've got 2 times 3 is 6 hydrogen, plus 2 times 2 is 4. So 6 hydrogen plus 4 hydrogen is 10. So in front of H2O, you want to put a 5, because 5 times 2 would be 10. Now, this 2 also gets distributed to the nitrogen, but I already have 2 nitrogen here, so I'm just going to make this a 1. Now what you want to do is count up all the oxygen on the right-hand side. I have 4 oxygen here plus 5, which is 9. When you have an odd number of oxygen, you put the odd number you want in front of the O2. Since you're putting it in front of O2, you're really doubling all the oxygen. If I didn't have this subscript, we'd be done. But since I do have that little subscript too, it doubled the oxygen. And if I double all of the other coefficients, I will be done. So 2 times 2 is 4. 2 times 2 is 4. 5 times 2 is 10. 1 times 2 is 2. So it's 4, 9, 4, 10, 2. Okay? Number 12 is the same way. You guys are going to need your Chapter 8 handout, your periodic table, a highlighter, and the worksheet titled Evidence for Chemical Reactions. Did you get that?
Highlighter.
Chapter 8 handout, your highlighter, a periodic table, and the worksheet titled Evidence for Chemical Reactions. Just your periodic table. So whatever one you've got. Number 12 is another combustion reaction. It's another hydrocarbon. Sometimes they contain other elements, okay? This is pure oxygen. You're forming carbon dioxide and water, and then sometimes you'll form another product. So what you want to do is balance the O2 last. Here I have 1 carbon on each side. I have 3 hydrogens here and 2 hydrogens here. I told you it is difficult to balance something when it's an odd number. So what you want to do is put a 2 in front of the CH3NO2, because 2 times 3 will give you 6 hydrogen. Put a 3 in front of the H2O, because 3 times 2 is 6 hydrogen. Then we've got 2 carbons over here, so we're going to put a 2 in front of CO2. Then I have 2 nitrogen, so we're going to put a 2 in front of NO2, like this. Now what you want to do is count up the total number of oxygen you have on the right-hand side, because we always want to balance the oxygen last when we have that pure oxygen in a combustion reaction. 2 times 2 is 4, plus 2 times 2 is 4, plus the 3 oxygen you have here. So 4 plus 4 is 8, plus 3 is 11. I have 11 oxygen on the right-hand side. I have 4 in the first compound. So 11 minus 4 gives me 7. I need 7 more. Put the odd number that you want in front of the O2, and you're going to double the rest of the coefficients, and you're going to be done. So it's going to be 4, 7, 4, 4, 6. And that's it. Now you can do the worksheet on balancing chemical equations.